If you know how to handle the numbers in a data frame, then you are good to do some plots. Let's have a look at a specific way of doing the plots using matplotlib. So first thing, we need to access our data. So I start by importing the function that we need to read the data, which in my case is read CSV. And having that function available, we can specify our data frame as calling that function read CSV and specifying the data file. So in my case, the data is contained in a subfolder called data, and its name is Everly's subdata.csv. Remember that if you have a Windows computer, instead of a /, that might have to be a \. Let's just see the head of that data frame, and that looks good. We have 2 columns and we see the first 5 rows by virtue of the head function. So I think we have everything prepared to do our plotting. For plotting, we use matplotlib, as I said, and from matplotlib, specifically the library called pyplot, we import a function which is called subplots, and that will serve to do our potentially multi-panel plots. So I have that function imported, and the way to use it is to specify 2 variables, one called fig, one called ax in my case. That's how we most often do it in the materials related to this course. And then just calling subplots with empty parentheses will already open a new figure frame. So fig refers to the fact that a figure environment has been opened, and ax refers to that coordinate system that you see displayed here by default, going from 0 to 1 on both axes. So let's now use this coordinate system to plot something into it. So the way to plot something into it is to refer to the coordinate system, means x dot, and then specify what kind of plot you want. So we want to start with a box plot, so I just specify that using the function boxplot followed by parentheses. Here you cannot go without an argument because you need to specify what data you want to have plotted. So data should come from our data frame, which we called df, and within that data frame, if I just go back, we see that the 2 columns have a name, which is calcium first and sodium the second column. So we can just refer to those numbers by calling that name. Let's do that. In square brackets, we say calcium, and if we now execute that little piece of code, we can see some weird information about matplotlib and followed by the plot. So if you don't want to see all this information about whiskers and caps and boxes, just put a semicolon at the end of that last command, last plotting command, and you'll get rid of it. And I want to show you one keyword argument that you can use to adjust this plot. So, for example, you might not be happy with the figure size. It's too small, too large, too wide, too high. To change the figure size, use the keyword argument fig size. And followed by equal, you can give the width and the height of that figure. And typically it's provided as an array, so if you use round parentheses it will be a tuple. You provide that in a tuple, and you can use, say, 5,5, a 5 by 5 figure, so square figure, and it will come up like this. And then you can of course change it. You can say 15 wide, and it will be a super wide figure, and and so on. And if you want to have it 15 high, then it will be a super high figure. That's maybe exaggerated. Let's go back to our 5 by 5. I think that's just as well. So now I want to build a more complex plot with a couple of sub-panels, and I'll show you the respective arguments that you need to use to build, in this case, a 2 by 2 plot. So 4 panels. How do we do that? First of all, I start by using that code. I copy that into a new cell, and let's see what we need to address this. So if we want to have from that data frame, which has 2 columns, we want to see the box plot of both variables, the calcium and the sodium, and we want to have a histogram of both the calcium and the sodium concentration. Then we can do that in a plot that has 2 columns, 1 for each concentration, and 2 rows, 1 for each types of plot. Right, so 2 variables or 2 concentrations we specify as 2 cols for 2 columns. And if we want to have 2 types of plots in different rows, and the n rows, which is the number of rows, is also 2. That will be a 2 by 2, a 4-panel plot. Now, if you have it specified like this, you also need to refer to each of the panels individually. So the first panel, the upper left panel of a 2 by 2 panel plot, will be 0, 0, because index 0 in row and index 0 in column. And let's just try, see what happens. So now we have a 2 by 2 4-panel plot, and we can see the calcium box plot is in the top left corner, just as we want it. So let's just copy that. So let's just copy that line, paste it here, and say in the second column we want to have calcium replaced by sodium. And executing this, we'll have 2 box plots, 1 for calcium on the left-hand side, 1 for sodium on the right-hand side. So how about putting 2 histograms below with the same concentration in each case? So what I do is I just copy those 2 lines, and first I change the row, namely both plots need to go in the second row, which has index 1. So axis 1, 0 and 1, 1 are now not box plots, but if I want them to be histograms, I put in hist in both cases, and if I just refer to calcium in the left-hand panel and sodium on the right-hand panel, this just works straight away. Right, so that's fairly straightforward. So now you see how to use subplots to create a multi-panel plot with different features. I want to show you 2 more extensions of that basic functionality, which only help to improve the way the figure appears. So first thing is we want to change the figure size, because you can see those values here for the sodium concentrations are somewhere in the 100s and sort of glued to the calcium panel. Too close, right? So what you can do here is you can just make it a little bit wider. So if you change it to 8 by 5, then these are more separated and maybe a little bit more nicer, and maybe a little bit nicer to look at. And the second thing is to put some labels on those axes. You know that when you submit a manuscript, the reviewers will complain if you don't put labels on each of the axes. So let's put some labels on each of the axes. Maybe we do that at the end. After we have done the plotting, we'll just address now the labels. So labels need to go, of course, with respect to the panel where you want them. So if we want to put a label here on the vertical axis of the calcium box plot, then we can do so by referring to the axis 0, 0. And if it's the vertical label, that is called the y label, and the function is called set y label, and then in round parentheses argument. So the argument that we need is the text that you want there, and that will be the concentration in both cases, right? And that first row, it will both be the concentration. So if we execute this code, now that we have the figure in a good shape, we can think of adding some labels to it. So because without labels it's very hard to understand which is which. So let's see how we can put labels on this 4-panel plot. So we first need to refer to the panel that we want the label to go to. So the top left panel will be 0, 0, and that panel should have a vertical label, which is called the Y label. And it's supposed to have a text which refers to what is plotted on the vertical axis of a box plot. Well, it's the values that are contained in that column, and specifically in our case of the Everly data, it's a concentration. So we just say concentration, execute the code, and we can see that now the word concentration appears next to it. So we leave that, we say that should apply now to both panels, and that's fine. For the histogram, that's different, right? So we want to have in the location next to the panels 3 and 4, so to speak, or the second row of the panels, we want to have the corresponding label would be in a histogram. That's not the concentration, but it's the count. So let's put that there. Let's copy this line, because we will do a set label as well, but in this case it will be row number 1. And of course the word concentration needs to be replaced by count. And if we do that, now we have the word count here in the right place. I think it looks good. Let's put some labels on the horizontal axis of the second row to specify that we are dealing with calcium on the left-hand side and sodium on the right-hand side. So how do we do that? So the bottom left panel is 1, 0, and we want to change its X label. And the bottom right panel is 1, 1, and we also want to change the X label. So instead of concentration, we now need to specify the what has been measured, and in this case it will be calcium on the left-hand side and sodium on the right-hand side, if that's what we used to call the data. So let's execute this code, and that worked, seemed to work correctly. We want want that text to disappear. We put a semicolon after the last executed function. Right, and the final thing, yes, just a small aesthetic thing. These labels are now very small, very tiny by default. I think it's 10 pt or something. Let's change it. That's an argument of the set label function, and the way to put in a second argument, separated by comma, we specify font size, and we put the font size to something more reasonable, which for example is 16. And so that will be a bigger font. And if I just copy and paste this font size to each of those labels, you can see now we have a plot with larger labels, more legible, and a nice overview that immediately gives you an orientation of what is what.